Our last topic for our Intro to Integrals unit is going to be about the mean value theorem for integrals. So before we really get into what the mean value theorem for integrals is, what we need to do is define what the average value of a function is. So in math, the average value of a function is defined as some value, we'll call it f of c, right? Such that if you drew a rectangle that had a height f of c, just like I've done here with this red rectangle, that has a width from A to B, that the area of that rectangle, that area in red, would be equivalent to the area underneath the curve f of x from A to B. So this area over here from A to B that's in blue. So effectively, the average value of a function is just the value f of c, the y value, that makes that rectangle's area equivalent to the exact area underneath the curve. So in order for us to figure out a formula to find f of c, we just need to write out something that represents this blue area and write out something else that represents this red area, and then set them equal to each other. Well, I think if we take a look at this, the area of the blue region is just the integral of f of x from A to B. So here we've got the blue area is an integral from A to B of f of x dx. We're going to set that equal to the red area. Well, the red area is just a rectangle. Its area is length times width. Its width here is from A to B, or B minus A. And its height is the value we're looking for. Its height is f of c. So the red area is just b minus a times f of c. And if we're looking for f of c, we just need to divide both sides by b minus a. We divide both sides by b minus a. We end up with f of c, the average value, is equal to, and I'm going to just write this as 1 over b minus a times the integral from A to B of f of x dx. And this right here is our formula that allows us to find the average value of any function. Now, the mean value theorem itself for integrals states that if you do have a function that is continuous on the closed interval from A to B, then at some point C on A to B, f of c is equal to that average value. In other words, if you have a continuous function, the function will actually attain that average value somewhere between A and B. Right? Now we can use this to find the average value, but we're only guaranteed that the function hits that average value if the function itself is continuous on that. So we're going to do a couple problems, and then we'll be done for this unit. We're going to try and find the average value of 4 minus x squared on the interval from 0 to 3. And then since we can clearly see that f of x, polynomial, f of x is continuous on the closed interval 0 to 3, we know that we're guaranteed that the function hits that average value somewhere between 0 and 3. So we'll find out where that actually happens. So first off, we know that f of c, our average value, is equal to 1 over b minus a, so 1/3 of the integral from 0 to 3 of f of x dx. So this should be pretty straightforward. This is now just 1/3 of this integral. Well, the integral of 4 minus x squared is 4x minus x cubed over 3. And we'll evaluate that from 0 to 3. So that's just going to give us 1/3 of, well, 4 times 3 is 12. And we've got 12 minus 3 cubed is 27. If we divide that by 3, we've got 9. So 12 minus 9. And then minus, well, if I plug in 0 to 4x and x cubed over 3, that's all just 0. So what we're looking at here now is 1/3 of 3, which is just 1. So the average value of 4 minus x squared on the interval 0 to 3 is 1. And so then we want to know, when does the function actually take on its average value? Well, all we have to do then would be to set our function, or set f of c, with one value equal to 4 minus c squared, which a little quick algebraic rearranging tells us that the c squared equals 3, or c is positive or negative root 3. Now, obviously, both those values, positive root 3 and negative root 3, do yield 1 in our function, but only one of them lies on the interval we're talking about from 0 to 3, only the positive one does. So we hit 1 at c equals the square root of 3. You can't include both of them because one of them's not on your end. We'll take a look at another quick one here. We're going to verify the mean value theorem for integrals for 1 over x on the interval e to 2e, and then we'll find all the values c on that interval where it hits that average value. So first off, we'll just need to set up our mean value theorem equation or expression, which is 1 over b minus a, so 1 over 2e minus e, times the integral from e to 2e of 1 over x dx. And of course, 2e minus 1e is just going to be e. So we've now got 1 over e times the integral of 1 over x, which is natural log absolute value x, evaluated from e to 2e. And so as we simplify this down, we have 1 over e, and then now we have natural log 2e minus natural log e. And I'm ignoring the absolute values because both e and 2e are positive values. And so as we simplify that down and we think about that, well, the natural log of 2e is the natural log of 2 plus the natural log of e. So coming over here, we've now got 1 over e times the natural log of 2 plus the natural log of e minus the natural log of e. The natural log of e is just 1, but whether it's 1 or not, the natural log of e minus the natural log of e is going to cancel out and become 0. And so this will just become natural log of 2 over e. And so the average value of 1 over x between e and 2e is the natural log of 2 divided by e. And if we want to know where it hits that value, just set 1 over x equal to the natural log of 2 over e and take the reciprocal of both sides. This occurs at x equals the reciprocal e over the natural log of 2. And this can also be done with a piecewise function. And whether the function is continuous or not at this point where it switches from being 4x cubed plus 3 to 3x squared plus 1 doesn't really matter for whether or not we can find the average value of the function, but it does matter for whether or not the function actually attains that average value somewhere in the interval. So first we'll find the average value, and we'll see how to do that. And then we'll check and see if the function is continuous to see if we need to see where it hits that value. So to find the average value, what we need is 1 over 3 minus 0 times the integral from 0 to 3 of f of x dx. The problem, though, is that on this interval from 0 to 3, we switch from being 4x cubed plus 3 to being 3x squared plus 1. So what we need to do is keep that 1/3 out there. But in order to find the integral from 0 to 3 of f of x dx, we need to separate that out into an integral from 0 to 1 of 4x cubed plus 3. and add that to an integral from 1 to 3 of 3x squared plus 1. So we're going to have two separate integrals to find, but we're then multiplying it by that 1/3. So we end up with 1/3 times the integral of 4x cubed plus 3 is going to be x to the 4th plus 3x. And that piece is going to be evaluated from 0 to 1. And then we'll add to that x cubed plus x. And that part's going to be evaluated from 1 to 3. So we've now got 1/3 of, well, if we plug in 1 to x to the 4th plus 3, we get 1 plus 3. And if we plug in 0, we get 0. And then we'll add to that the evaluation of x cubed plus x from 3 to 1, from 1 to 3. 3 cubed is 27, so we've got 27 plus another 3 when we throw that 3 into the x. And then we'll subtract from that, well, plug in 1 to x cubed plus x, and you get 1 plus. And through all of that, looks like we've got 1 plus 3 is 4, and 27 and 3 is 30, so we've got 34 there. And we're going to take that 34 and we're going to subtract 2 from it, so that's going to be 32. And it comes out to be 32 thirds. And so the question up here asks us, does the mean value theorem for integrals guarantee that the function actually takes on that value on the given interval? So in order to determine that, we have to determine if this is continuous at x equals 1. And we know it's continuous from 0 to 1 because that's a polynomial. And we know it's continuous from 1 to 3 because that's a polynomial. But the question is, do these things meet up at the same point at x equals 1? So we'll look at the limit as x approaches 1 from the left of f of x. And that'll be the piece that's approaching it from the left-hand side, the 4x cubed plus 3. So that'll be 4 times 1 cubed plus 3, which is 4 plus 3, or 7. And then we'll look at the limit as x approaches 1 from the right of f of x, which will be 3 times 1 squared plus 1, which is 3 plus 1, or 4. Since 7 doesn't equal 4, we can see that f of x is not continuous on the interval 0, 3, because it has a jump discontinuity at x equals 1. So we'll say mean value theorem for integrals does not apply. And it is not guaranteed that f of x actually hits 32 thirds somewhere on that interval between 0 and 3. That doesn't mean that it doesn't, but the mean value theorem just doesn't guarantee that it does. And that is where we're going to finish up this unit. We've got 2 units left for the year. We've got differential equations and then applications of the integral. So that's it for our basic Intro to Integrals unit.